Hi, in this video we are going to see how we can use Amazon Sagemaker to train and deploy any LLM model, and in today's video we are going to do that with Mistral 7B model. So before diving into Amazon Sagemaker, let's see what is Mistral 7B. So as we can see on Hugging Face, so this is a Mistral 7B version 0.1 that we are going to fine tune today. It has been pre-trained on 7 billion parameters before, and we can also see model files and all other different files which comes along with this model. Okay, so now what is Amazon Sagemaker? So using Sagemaker, it is like very easy to train any model, deploy it, and also then use it in the external world for inferencing. So let's go to Amazon Sagemaker first. So when you log in into your AWS account, you would see something like this as the dashboard. And now what you need to do, you need to create a notebook using which we'll be able to fine tune and deploy. As you can see, I have already made 2 notebooks here, but in our case, I'm going to show you how you can create a new notebook and then use it to train and deploy your LLM model. So let's go to this create notebook section. You can give your instance name, notebook instance name. Then there are different kind of machines that you can select from, using which this notebook would be running. And then there is this platform identifier. You can make it as default. And now comes the permission and encryption and the IAM role that you need to select. So since I've already made this Sagemaker execution role, you might need to create a new role giving the proper permission to this Sagemaker execution role. So I'll show you what kind of permission do we actually need to use this role for with notebook. So this is the Sagemaker execution role that I have created today. And as you can see, I've given Amazon Sagemaker full access to this role. So whoever is going to use this role, they'll be having the full access to the Amazon Sagemaker. So that was about the role, and you can leave all these options as default, but there's one additional feature here that you can clone any GitHub repository by default to the notebook that you're going to open. In our case, we are going to use my own repository which I have pushed here, and we can just copy paste the URL over here to copy all the files in this repository to the Jupyter Notebook environment. Once this is done, you can then click on create notebook instance. Once you click on create notebook instance, you will be able to open Jupyter Lab on the notebook that you have created. So for example, I've already created this notebook in the similar way which I've explained, and on the right side you can see this open Jupyter and open Jupyter Lab. So we are going to use this open Jupyter Lab to open the lab. Okay, once you see this Open Jupyter Lab page, you can see there are different notebook environments which you can use, and also different notebooks. So in our case, the repository which I have pushed, you can find this train and deploy LLM. You can just double click on this file, and you would be able to interact with the Jupyter notebook that I have created. And also with every notebook, there's this kernel that we have to use. So by default, we'll be using this Conda Python 3 kernel to run this notebook. Okay, so now we are going to start with the process of training and deploying the LLM. So first we are going to train the LLM. In our case, it is going to be Mistral 7B, and then we are going to deploy it. So first we'll go with the installation steps. So we are going to install the transformer, dataset, Sagemaker, Gradio, and so on. So in this step, you can see we are also upgrading the datasets, because while I was executing the notebook, I saw some issues with the dependency. So we have to just upgrade the dataset package so that there are no issues. Once both of these commands are run, after that, we are going to log in into our Hugging Face. So here in Hugging Face, you have to specify your token. I have currently hidden it, and I previously ran that. So that's why it's not being shown here. Okay, so once you enter this token, you will be able to log into your Hugging Face client, and also then use it for data purpose. After that, as you can see, here we are printing out Sagemaker role, bucket, and the session region. And we can verify that everything is working fine. If you get some error while doing this, most probably it's the permission issue, because of which you're not able to access the Sagemaker role or the bucket. After that, we are going to load and prepare our dataset, and in this case, we are going to use this Databricks Dolly 15K dataset, and we can also search it on Google what it is about. So if we go to the Hugging Face website, we can see it consists of different kind of instruction, context, response to the instruction, and also different kind of categories which are involved here. So we are going to use this dataset to fine tune our Mistral 7B model. And if we want to print the dataset size, so there are around 15,011 rows in this dataset which we are going to use for fine tuning. After that comes the formatting part. So every LLM model has its own way to accept the prompt and also generate a response. So in this case, we have created this function format dolly, which is going to take the sample, and inside the sample we could find instruction, context, and response. So we are going to like append all this together and return the prompt. After that, we can also randomly select a row from the dataset, and using format dolly function which we have created, see like how we are getting the output. So instruction is how are you today, and we also get an answer from the LLM in the way we formatted it. After that, we are going to use the model ID Mistral 7BV01 and use it to initialize our tokenizer from auto tokenizer. Once that is done, after that, we can see like we are going to print how many total number of samples are there in the dataset which we are going to create now. So in this first, what we are doing, like we have this utils command in the scripts folder. Let me show you. So as you can see, there is this pack dataset command which we have. We are going to use a function which is like pack dataset, and it has its own logic of chunking the sample that we are going to have. And then once the chunking is done, we are going to use it with the LLMs to fine tune it. So as you can also see, after the formatting is done, we are also appending end of string token after every sample. So generally, like this is like an important step. And once you have like specified end of token, it becomes easier for LLM to understand where the exact sample is ending and when to generate new data. So we are going to iterate through each and every row of the dataset, and using the map function, we are going to give the row to this template dataset function so that it can be converted into the new format that we want. And also we are going to remove all other features from the dataset. After that, the auto tokenizer thing that we have done above. So we are going to tokenize our whole sample, which is going to be batched, and also we are going to remove the columns. Once that is done, we are going to use this pack dataset function, which is in the utils file, to chunk it properly. And we have also specified the chunk length, and then we are going to print the total number of samples. And also above we have seen like there is one sample row that we are printing, and that's the sample here. Provide a bullet list of the things to think about when buying a house, and there's this answer. And then there's total number of samples that we have print after chunking. Now after we have processed this dataset, we are going to save it to a location, and it is S3 in this case. So the dataset that we have prepared, we are going to store it into this S3 location. So I can, since I've already ran this notebook once, so I'll show you like where it is going to be stored. So this is a bucket name that it automatically created when we created this notebook instance. So inside the process folder, we can see there's this Mistral dolly train, and there are like these 3 different files which were created when we ran this cell to upload the dataset that we have just created. Now comes the fine tuning part. So there is this method called QLoRA that we are going to use. Generally, this is used when you want to optimize on the VRAM that is used while fine tuning. So you can optimize on the VRAM so that lesser VRAM is used while training or fine tuning any model. So these are all the hyperparameters that we are going to use while training the model, which consist of learning rate and different number of epochs and the dataset path and so on. To get more details, you can always go to the internet and learn more about each of these parameters. And also we have ensured like we are also giving Hugging Face token to this hyperparameter list. Once that is done, we are going to create one object of Hugging Face class to create an estimator. Here you can see the entry point is run QLoRA py. So we have this separate run QLoRA file, which is going to like create a PEF model. And also there is this training function to define how the training needs to be done on this Amazon SageMaker. We have also defined the instance type here. So what will happen once this training job is started, it is going to spawn one new instance of this type, and the training will be happening on that instance. Make sure that you have proper allocation of the instance before running, otherwise you will see an error where it will say you have to allocate quota for these instances to start the training process. Okay, once that is done, now comes the training part. Using Hugging Face estimator.fit, and we are passing the data to it, the training process will start. Since training process is a long, it will take a long time. For me, it took around 4 hours to complete. That is why I've already ran all the cells before, so that we don't waste time on this recording. And as you can see, first it downloads the datasets and the model, the pre-trained model, and then start the fine-tuning process. So here it is downloading all the model weights and everything. And here is where like the model training part has now started. So here the model training is now completed. It took around like 3.9 hours and $2 per hour to complete the whole training process. And so it is estimate around like $8 for the complete process to be completed. And then once the model is trained and fine-tuned, we can upload the created model to S3 bucket again. So I'll show you like the location where this model got stored. So this is the output directory where the model got stored, and in the output we can see the model files. So these are the files which were created today once the model has finished the fine-tuning process. Once your model is now trained, we can start with the deployment process. So there are different ways of deploying this model. So first we are going to like create an endpoint on Amazon SageMaker so that it can be used by anyone outside our private network. So there's this concept of LLM URI that gets generated using the SageMaker. So once we like print this LLM image path, so you can see like there's this specific URI which gets created, which can be referred afterwards to access this model. After that, we can see like this is the model path that we are going to use. Then comes the instance type. So after the training process of the model is finished, we can deploy a model, and to deploy a model again, we can select the instance type, like on which instance we want to deploy this model. So in our case, it is going to be G5 2x large, and again make sure like you have the appropriate permission and the quota available to deploy this instance. In the config, we can see the maximum input length and the total number of tokens. So generally these parameters are used to define what would be the maximum length of the tokens which would be generated by the LLM model, and the input length specifies like what would be the maximum input length of the prompt that you are giving to the model. After that, we are going to create this model variable using the Hugging Face model, where we have provided the image URI and also the model data path where the model weights are stored. Once that is done, we can simply use this LLM model.deploy function to deploy it on Amazon SageMaker on this instance type MLG5 2x large. It will take around 10 to 15 minutes to get the deployment process done. And once the deployment process is done, we can now start using the new fine-tuned model. For doing that, first we have created this format prompt function, which takes in the message, history, and system prompt to create and generate a prompt, which can be directly given to the input of the LLM model to create a new prediction. So as you can see in this format prompt, we have given our query, which is what is deep learning model. Since there is currently no history, we are giving it as empty list. And just to give a system prompt, we are saying that you are a helpful assistant, to define like what is the role of the assistant. Once that is done, we are preparing a payload where we are giving inputs as the formatted prompt and the parameters. So there are like different parameters for different models. In this case, we have defined top speed, temperature, maximum number of new tokens, and also the stopping criteria, like using which tokens LLM would understand it's time to now stop and not generate new tokens. So let's try to run this again. So it is going to do an inference, and once the inference is completed, it is going to generate a new text. So as you can see, the question was what is deep learning, and the model is able to output the proper answer after our fine-tuning process. So this was the way one in which like we can do the inferencing. And now let's say we have some external client using which we want to invoke this model. That can be also done. So we want to just import the Boto library, and we can specify the client name, which is SageMaker runtime, and we have like some custom attributes and the endpoint that we have to define. So this endpoint we do get from the Amazon SageMaker, that I'll shortly show you like where is it present, and then simply we just need to invoke the endpoint.
It's 5 o'clock.
And also dump the payload that we have also created earlier in terms of body. And once the response is generated, we can like parse it in the form of JSON and generate the text out of it. So similarly, like you can see, we have also generated a response again using this Boto library. After the model is again deployed, so we can also stream the response. And now we are going to create like a Gradio application, which would be inbuilt into this Jupyter notebook, and using which like we can interact with the model which we have deployed and also see the response of this LLM model that we have created. So again, we are going to specify the same parameters, format prompt, and then we have like this create Gradio application where we are giving the endpoint of the LLM model, Boto session, and different other parameters. So from where we are getting this create Gradio application. So if we go inside this SageMaker chart, so there is this function SageMaker chart. Let's see like where it is. Yeah, so inside the demo folder, we see there's this file SageMaker chart, which is creating this Gradio based UI using which like we can interact with the model that we have just deployed. So once we like run this, you can see it is also giving us a public URL which we can use to interact with the application that we have built on Gradio, and also directly we can interact with it here. So let's see. So let's try to ask it something. What is deep learning, or what is generative AI? And using the deployed model, it is now able to answer the questions or the queries that we have entered here. And also it stores the chat history. So as you can see, like in the previous query, we have asked about generative AI. In this query, we have asked about large language models. It is able to like differentiate properly, like what is generative AI and if it is an umbrella term and what is exactly large language models. Okay, so once the process of deployment is done, and we have also seen how we can use it, now what we are going to create, like we would enable the public internet to use this deployed model. And how we are going to do that? First, we are going to create a Lambda function using which like we would be able to access this model, and then we would be creating an API gateway on AWS, which would access the Lambda function, which in turn would be accessing our deployed model on SageMaker. And we can also visit SageMaker dashboard to see our deployed model. So as you can see, like this was a notebook that we have created to deploy the model. And in the dashboard, we can also see the training jobs that was there. So this was a training job that we ran, where we can see like different kind of timestamps of different steps while training, and also some other logs and the parameters that we have passed for training. You can see the GPU utilization, CPU utilization. So that is all about the training job. And now coming about the inference and the endpoint part. So you can see like once we have like deployed the model, it also creates an endpoint for everyone to use. And we are particularly interested in this endpoint name that we are going to use at other places. So if you go back to our repository, so I've created this Lambda function where we can exactly find the Lambda script which can be used to invoke our deployed function. So what we are going to do, we are going to go to the AWS Lambda and going to create a new function. So let's start with like creating a new function. So here we can like specify any of the name that we want to keep for our function. Since I've already created one function, I'll just show you like how I created that. So here we can maybe write generate Mistral 7B response. Here in the runtime, we are going to select Python 3.10. Then comes the execution role. So here, one thing that we want to remember is while we are going to create this role, it should have the access to the Amazon SageMaker. And to do that, what we are going to do, we are going to first select the basic role which is there, Lambda, like create a new role with basic Lambda permission. And after that, we are going to add new permission to access the SageMaker. So that part I'll be showing you. So once this is done, you just need to like hit on the create function. And then after that, we'll go to the IAM. And inside IAM, inside the roles, we are going to see the new role that this Lambda function created, which is a generate llama 3b. So inside this, initially you would only find this Lambda basic execution role, but you need to now add new permission so that it can also access the SageMaker. So in our case, like I have added this new permission, invoke endpoint. And how did I do that? I just go to the add permission, create an inline policy, and just you can like copy paste this part to create a new policy and then attach to this role. Once this process is completed, we would be seeing like a Lambda function, which would be like empty initially, but using the code which I have specified here, you can just copy paste this code into this Lambda code and you would be seeing something like this. So here, first thing is endpoint name, which we have defined in the environment variable. So how do we define the environment variable? You go to the configuration, you go to the environment variable, click on edit, you add a new variable. In this case, it is endpoint name, and we add the value of the endpoint name. And how do we get this? We get it from the deployed version from the Amazon SageMaker. So we'll just copy it and paste it here to create a new variable. and click on save. We'll come back again to the code. So we have defined the endpoint name, we have defined the runtime variable, runtime Amazon SageMaker, and then we have the same function for format prom, in which we can pass in the user query, and the thing which it will return, we'll directly pass it to the LLM model so that it is in a structured way as expected by our LLM model. Okay, once that is done, then there's this default Lambda handler function where we are going to parse the data which is coming through the API. We are going to print that. Then we are going to define some parameters that we also did before. Then created a formatted prompt. We created a payload in which we can define the input and the parameters which we have defined here. And then we are going to use the same function, runtime invoke endpoint. Endpoint name came from the environment variable, context type, and also the body which we have just created. Once this is done, we are going to print the response, and then we are going to parse the response in form of JSON and create a final response. And once we get this generation output, there is this field called generated text, which would actually store our generated output. And then we are simply going to return the response to the API. So just to test this quickly, we can click on test button and configure the test event. And here, since I've already created one new event, we can just simply pass the query that we want and click on the invoke function so that it can interact with the Lambda function which we just created, and in turn it is going to use the deployed model which we have and return the response. In this case, we can see the body which it has returned is this. AWS SageMaker is a fully managed service, and so on. So for the prompt that we have, which was the prompt? Let me check where it is. Okay, so the prompt was given in the test thing. What is AWS SageMaker and how it is helpful, and in response we can see it has given the full thing about Amazon SageMaker, what it is about. So this way we have tested our Lambda function, and now what we are going to do, we need to like expose it to the public internet so that it can be used by anyone outside our local internet. So for doing that, we are going to use API gateway. So we are going to use the API gateway which is provided by AWS. So since I've already created one API gateway, but I'm going to show you how to create a new API gateway. In this case, it is going to be a REST API. We are going to click on the build button, new API. We just need to give a name. And this can be anything. And create API. Once we have created this, we need to create a API create method. So we click on this create method. In this case, it is going to be of type post. It is going to be a Lambda function. Then we define which Lambda function it is going to use. So in this case, it is going to be the Mistral function that we just created on Lambda. Authorization is none. There's no query string or HTTP header that we want. And we'll just click on the create method button. As you can see, now we have like created a new method here. Now we want to just deploy this API. We want to like choose a staging, like the stage of this API. We can maybe give it as staging, the name, deploy. Once that is done, you are going to get this invoke URL that we are going to use to invoke the model that we have deployed. So let's copy this, or maybe use the one which I have already created before. So I think this was the one which I created before, the same way. I'll just copy the URL. Or that I already have in my Postman, so I'll directly open my Postman. So this is the Postman. So the URL that we got from the API gateway, we'll just paste it here directly. And in the body, in the raw format, we are going to insert the query that we have. It can be like anything, and just remember it's going to be the post request, so because we have specified the method there. And once we like click the send request, it is going to first go to the API gateway on AWS, then it is going to go to the AWS Lambda, and then it is going to interact with the Amazon SageMaker deployed model to get back the response that we are seeing here. So this is the way in which like you can deploy any of your LLM models using Amazon SageMaker. So just to do a quick recap of what all things we have done. So we started with this repository that I've created in which you can find the Jupyter notebook to fine tune and train your model and also then deploy. Then we like went to the Amazon SageMaker. We created quickly one of the notebooks. So where can we see that? So in the notebook section, you can see all the notebook instances that you have created. So in our case, it was this one. Once you go to Jupyter Lab, you can access the notebook, and then we have seen like how we can prepare the data first. We uploaded the data on the S3. Then we fine-tuned our model using QLoRA method. And then we started the training process, which took us around 3 to 4 hours to complete the training. Once our training is completed, we uploaded the model on S3 for later usage. And then we have deployed the model on Amazon SageMaker again. We got an endpoint URL, and then we have seen like how we can inference using the deployed model. So one way was to like create a Gradio application with a public URL. Other way is to like create a Lambda function, create an API gateway, and then maybe use your Postman or any other client to reach out to your LLM model and create an inference out of it. So that is it about this video. Thanks for watching.